Sorry, Faith.
Put tape around it, tape around it, and then got it is?
Okay, so if you got any questions on anything in the DMR? Are you good on the DMR? What was the DMR? You were kind of like...
I got so I did like okay, I just had to
Okay. I just wanted to check with you. You seemed a little unsure. Yeah. Okay. Okay, so we'll do number 4. Yeah, or do you go follow up?
Well, I just
Yeah, I remember. Okay, so
I found my yellow.
yeah, so 126 over 7. Then you subtract then
Like this and that. Well, great. Break that one more
where's the you've got y to negative 1, y to the 2. So whenever you're multiplying
solid.
that's why y to the 1.
Yeah, so it's 60. It's 7. Once you took the 5 years of Russian, never used it.
Colton, you want to do a big question?
So it's just 4.
Sorry.
It's 7 times
4. Okay, hey guys, lots of folks wanted to chat about 4, so let's do that now. I need to do a little rearranging here on the screen. Okay, so here's 4. I don't have a preset way of how I'm going to do this, so if I do something that doesn't make sense, you let me know. Anybody can certainly do that. So when I look at this, the first thing I see is that x to the 10 over x to the 5 could be simplified. So the first thing I would probably write would be 14x to the 5th, y to the negative 1. Something like that. Does that make sense?
Yes.
Whenever you're dividing bases, you just subtract your exponents. Times, over here in the numerator, 3 squared is 9. X to the 4th squared is x to the 8th. And then y to the 1st squared is just y squared. Down in the denominator, x to the 0 is 1. So that's just 7 times 1, which of course is 7. Still making sense? Any questions? All right. So maybe I want to multiply now. I could do 14 times 9 is 126. X to the 5 times x to the 8 is x to the 13. Remember, if you're multiplying bases, you add your exponents. And then same rule here, y to the negative 1 times y to the 2 is y to the positive 1. Still over 7. And I think the final thing I would do is recognize that 126 apparently is divisible by 7. Apparently 18 times. Probably use the calculator for that one. Who knew? So 18 x to the 13 y to the 1st. Colton, as always, sounds really great in my head. I don't know. Does that make sense to you? Okay. Where I see people running into issues a lot is dealing with the 126 and the 7. A lot of times we want to subtract those. Remember, it's just division. It's just doing 126 divided by 7. So it's easy to overcomplicate that stuff. Yeah?
Could you just, I just took the 7 cross out and then took 14.
Totally. Yep, you could do that.
Okay.
Yep, I like it. So you could look at this as being over 1 and then say, well, this is in the numerator, that's in the denominator. That's a 2, that's a 1 when you divide out the common 7. That's a great strategy as well. Reducing early.
The y, I just didn't put 1, I just put y.
Yep, Yep. Y to the first or Y. Totally fine. Yep, great. Great question. Thanks for asking. All right, so if there's not any other follow-ups on 4, anything on 1, 2, or 3? Amy and Billy giving us a little trouble?
I'm missing
Yes.
one element.
Okay. Okay. So let's take a look at Amy and Billy wanting to play at the park. Okay, so as you know, I'm a fan of a picture. So I'm going to draw a picture of this. I'm going to say that here is their house. I'll put H for house. Park is over here somewhere. Based on the way that I read this, I can tell right away that Billy gets a head start, heading to the park, right? So Billy jumps out here. He gets his head start. He continues on towards the park. I'm going to call that distance of Billy, dB. Amy, for whatever reason, did not get the same head start that Billy did. And so she, when Billy is out there, she finally leaves the house. She is much faster, so she catches up to him somewhere out there, heading towards the park. I'm going to call that distance of Amy. So can you guys tell that the distance of Billy and the distance of Amy, as I've labeled them, they are different, aren't they? Billy got the head start, so his distance during the time we care about is shorter than Amy's. I'm curious, how big of a head start did he actually get?
309.
How did you get 390?
So he left 130 seconds, and he's walking 3 feet per second. So if you multiply the 2, you get 390.
I give you your distance. That's right. So that's a really important thing to realize, that you can just multiply rate times time to get distance. So his head start was 390 feet. So once you get to this point now, we got it, and this is always the hard transition. No one's saying that it's easy. This is a skill that you can be good at or bad at, but you can improve wherever you are. You can always get better. We need to look at this picture and think about the words that we read up before and ask ourselves, what is true? Like, what would be a relationship that actually truly reflects what's happening? Let me give you some bad relationships. Check this out. This would be incorrect. Why is that so bad? It's just not true. Just simply not true. Distance of Billy does not equal distance of Amy, because he got the head start and she caught up to him. So, just not true. I could also say this. How about distance of Billy plus distance of Amy equals 390? This is one of those ones where I'm just like throwing stuff on the paper hoping something sticks, right? I just, I don't know if that's true or not. I don't know if it's false or not. I'm just like throwing some stuff out there. Anybody have any idea about like an actual true relationship that reflects this? What do you think?
Distance of Billy plus 390 equals distance of Amy.
That's right. So you take the shorter distance and you add that head start, then you get the longer distance. So that'd be where I would start my equation. So that's the relationship we want. Kind of the final step before we finish this is to remember that distance is the same as rate times time. So Billy he walks at 3 feet per second. So his distance would be 3t using the rate times time relationship plus 390 equals, Amy is much faster at 10 feet per second, so her distance would be 10t. So I say this is the end because all we have to do is just a little bit of algebra, and I think you guys are all really good at that. So subtract the 3t over. 390 equals 7t. Dividing by 7, apparently that's whatever I said, 55 point something, 7? Okay. Whatever was missing, did you get it?
Yeah, I
Okay.
mixed things up.
Okay. It happens. It happens. What else? 1 or 3? Doing okay with 1 and 3? All right. Okay, fair enough. So what we're going to do here right now, I hope you'll have fun with this. We're going to have the board. We're going to see how much you guys are remembering from last time. And yeah, so grab a marker, grab some space, or grab a small board. Either way works.
Can I erase this one?
Yeah, you can erase anything that's up there. With a question like this, did you notice that one of the first kind of odd things here, strange things, is that there was no blah, blah, blah equals 0? Let me tell you, We need that. We need everything on one side equals 0, and that's not what we have. What would I need to do to get this to a place where I've got everything on one side equals 0? That's right. So what this really should look like is this. 10x to the third minus 5x squared minus 5x equals 0. So please notice that I subtracted the 5x squared over and I put it in descending order. Before you race off too fast, one other thing. Before I do any 2x2 box stuff, I need to make sure that I have factored out a GCF first. So before you even think about a 2x2, factor out any GCFs you might see, and then proceed. Okay, so give this one a try. Keep going. Well, please check this out. Step 1 was to get into standard form here, right? Step 2, and I can see that a lot of you, most of you, have done this pretty well. Hey, ladies, could you quiet down, please? Thank you. Most of you have done this pretty well. We need to factor out the common factor. Do you see how there is a 5 in common amongst all the terms? And an x? Does that make sense? I hope it does. Let me show you what I'm talking about and see if you agree. There's a 5x in all three terms. So that would leave me with 2x squared minus x minus 1 equals 0. Looking around, I saw a lot of folks got to that place. So we're not quite done with the factoring yet because what's on the inside here, that's one of those trinomial, one of those quadratics. What tool do we use to factor a quadratic? Yeah, what dimensions on the box?
1 by
No, 2 by 2. For a quadratic, it's always 2 by 2. So what I'm going to do now, come off to the side here maybe. Nah, and I'll do it right here. So I've got, please pay attention. I've got 2x squared. I've got minus 1. What's my AC for the quadratic? My AC is negative 2. The good news is there's not that many ways to multiply to get negative 2, is there? What are they? Negative 2 times 1 or negative 1 times 2. That's it. So which of those actually adds up to be my B? First one. Yep. So that gives me negative 2x, negative 1x, or positive 1x, sorry, right there. And then I factor as normal. So I factor this way, what's in common? 2x. I factor this way, what's in common? What about that one? It's a 1, right? Plus 1. Then I factor in the green direction like this. What's in common? Negative 1's in common. How about this one? Just an x. So this leaves me with this factoring. Check this out. 5x times 2x plus 1 times x minus 1. The truth is, really, we could say that this actually has 3 factors, right? You could say 5x is a factor, 2x plus 1 is another factor, x minus 1 is a third factor. I need to set all 3 of these equal to 0 and solve. So this would be 5x equals 0, 2x plus 1 equals 0, x minus 1 equals 0. For the left one, just dividing by 5 gives me x equals 0. 1 in the middle, if I subtract 1 and divide by 2, I get x equals negative 1/2. On the right, I add 1, I get x equals 1. So this one actually had 3 answers. You could even have one that's got like 4 answers. Lots of ways it could go. What do you think? Feel like something we should practice again tomorrow? Yes. Okay, we will. We'll for sure do that. Hey, go back to your seats. Get ready for your concept quiz.
Why? I have a question. Not that it's progressing, but why do we